most recent CR lead class here for putting together this guest speaker series. I've really enjoyed all the talks so far, quite a bit, and I'm honored to be one of the presenters here today. So we're going to be going from South Florida to the Black Hills, slightly different area in general. I just want to start out by talking about how rare QLCS tornadoes are in the Black Hills. So the Black Hills are located along the Wyoming-South Dakota border, roughly marked there by that yellow star if you haven't been in the area before. In the recent QLCS climatology paper, Ashley and his co-authors showed that the percentage of tornadoes in the Black Hills region that were associated with QLCSs is really very low. Most of our tornadoes tend to come from supercells out here. And in a more anecdotal matter, our SU, Dr. Matt Bunkers, he's never seen such an event over the Black Hills here, and he's been working in the Rapid City area for about 20-25 years now. So overall, fairly rare events that we had last summer. And indeed, that all changed on the evening of July 4th. So we had 3 QLCS tornadoes that occurred in about a 10 to 15 minute span over the Black Hills. Each of these ended up being rated EF1 and produced mostly tree damage, as you see from the images from storm surveys there. Mostly traversed forested land for the most part, although there were some campgrounds nearby. But fortunately, there were no injuries, no structural damage to speak of. Fortunately, Harry Styles was not camping in the Black Hills last summer, so we dodged a bullet there. Now, well, before I go on to that, but despite these being rather low impact tornadoes in the end, this presentation isn't necessarily a success story. Having worked the radar that night and then having looked more closely at all these data in post-mortem, I realize now that I could have used the 3 ingredients method and also the TWIP confidence builders and nudgers to possibly provide warnings with some lead time here. Because although each of these tornadoes ended up being detected in real time, none were warned with any lead time. So my main goal with this presentation, which was originally developed for this year's spring training at UNR, was to identify how to use these available data to provide better service in the future, such events like this one, although they do tend to be rare out here. So now going to the 3 ingredients method. Most of you are probably familiar with the 3 ingredients method by now, but just as a reminder, these 3 ingredients are meant to highlight areas along a QLCS with a relatively high potential of producing a Mezzo vortex in the next 30 to 45 minutes or so. And these include a nearly balanced or slightly shear dominant system cold pull and ambient low level shear. Also include line normal 0 to 3 kilometer bulk shear magnitude of at least 30 knots. And then also a localized surge or bow within the QLCS. And with those ingredients met, you can then use the confidence builders and nudgers, which are shown on the left, or excuse me, on the right there. Those could be used to increase confidence in potentially issuing tornado warnings with any of these mesovortices. So for this presentation, I want to start by looking at a couple of the environmental considerations, which are the 0 to 3 kilometer bulk shear and the 0 to 3 kilometer cape. Now, Patrick Marsh from the Storm Prediction Center was kind enough to provide some archived mesoanalysis fields centered on the Black Hills for use in this presentation. So thank you first to Patrick there. And here we're looking at the 0 to 3 kilometer shear, and this is from the 0Z mesoanalysis. Recall that the QLCS tornadoes from this evening occurred about 2:15 to 2:30 Z. So these plots are from a couple hours prior to the event of interest. At this time, the QLCS was over in northeastern Wyoming. And at this time, you see that 0 to 3 kilometer bulk shear was approximately 30 to 35 knots from the west-southwest. If you go forward to 1Z, little has changed by this time, and we're now about an hour to an hour and a half prior to the tornadoes. Values may have decreased slightly near the Black Hills, but overall still in the 30 to 35 knot range. Going on to 2Z, which is approaching the time of mesovortex and tornadogenesis, the mesoanalysis now suggests that 0 to 3 kilometer shear had decreased a little bit, but values of approximately 30 to 35 knots are still in the vicinity of both the central and southern Black Hills. And you could see actually the wind barb there south, or the shear barb, I suppose, south of the yellow star is still showing 35 knots at that time. You can also look at effective shear, as Ariel was mentioning in the last presentation, to get a sense of how well the deeper layer shear is supportive of sustained updrafts, potentially rotating updrafts. But in this case, the effective shear you can see is about 40 to 45 knots. So that, looking at a deeper layer, is also indicative that the potential is there for some mesovortex genesis. And then looking back at 0 to 3 kilometer shear at 3Z, which is after the tornadoes actually occurred, the magnitude is about the same as it was at 2Z on the Mezzo analysis. Now, 0 to 3 kilometer shear at times was a little borderline. 0 to 3 kilometer cape was not throughout the event. So at 0Z here, we already see a bullseye of values well over 100 joules per kilogram over and near the Black Hills. And these values just blow away that nudger of 40 joules per kilogram. At 1Z, the bullseye is even more centered in the vicinity of the Black Hills, with the the values over the higher terrain there are now exceeding about 150 joules per kilogram. As you step a little bit closer towards mesovortex and tornado genesis, you now have a 175 joules per kilogram contour showing up. So at least based on the Mezzo analysis fields at this point, the low-level buoyancy is primed for mesovortex genesis and potentially tornado genesis over the Black Hills. Now, as the QLCS moves through the Black Hills and starts to move off to the east, the values over the Black Hills accordingly would, as you would expect, do decrease by 3Z, with the maximum shifting east of the hills and the foothills at this time. Then by 4Z, poof, it's gone. The bullseye over the Black Hills is essentially eradicated by that point. So to briefly summarize the environmental factors before we start to dive into some radar data, both the 0 to 3 kilometer shear vector magnitude and the 0 to 3 kilometer cape would suggest that we have increased potential here for mesovortex genesis and potentially tornado genesis as the QLCS approaches. And in particular, that second ingredient of the 3 ingredients method would be met if there was a surge or bow that was directed towards the east or northeast. So it'd take full advantage of the 0 to 3 kilometer shear. Also, the low-level buoyancy is well above that TWIP nudger threshold of 40 joules per kilogram that I referenced. And this event actually made me wonder if such a bullseye might be common over these areas of relatively higher terrain, particularly in the evening time as you start to get low-level nocturnal stabilization setting in over relatively lower elevations. So this event in particular has led to some potential research avenues as we go forward. Now diving in to the radar data just a handful of minutes prior to the first tornado occurrence. You see several features of interest already, which I have highlighted, but just to orient you, we're on the western side of the Black Hills here, climbing in elevation generally towards the east. And Rapid City and also our radar, which is at New Underwood, a little bit east of Rapid City, are to the east of this image by a ways. At the lowest tilt here, which base reflectivity and storm relative velocity, both of these products are at the lowest tilt, 0 to 5 degree tilt. At that level, we're looking at about 4,000 to 4,500 feet above radar level, and potentially above ground as well. It's a little iffy as you get on that side of the Black Hill. So basically, it's not ideal. We're almost out of the range where you can start to resolve some of these features. But as the QLCS moves closer, we are beginning to resolve some of these key features a little bit better. Now, I'll start by noting that the system's cold pool and the ambient low-level shear appear to be nearly balanced based upon the updraft, downdraft convergence zone there. Throughout the majority of that line, from roughly where I have the inflow notch marked at the north down to the reflectivity nub there in the south. Now, along the southern edge of the QLCS, we have a pretty clear reflectivity nub there and a surge in the QLCS. So we have all 3 ingredients here fulfilled. We also have an apparent inflow notch and a tightening vortex at this time. So based on these features alone and the prerequisite environmental information, you could probably already make the case for a tornado warning here. And this is roughly 7 minutes or so before the first warning was issued, and a handful of minutes before the tornado actually occurred. And near the northern edge of the line, you also see a potential inflow notch, but also a rear inflow notch with what appears to be a reflectivity drop up there. So several confidence builders are all kind of lining up along that northern edge. You also see a couple of surging or bowing regions to the west of Rochford there. So in this location, the three ingredients also generally appear to be fulfilled, and mesovortex genesis is already ongoing at this point. You start to see a little bit of a convergent rotational feature there west of Rochford. And again, you can make the case for a tornado warning probably at this time. Go forward another 2 minutes, and the northern area of interest shows a more clearly developing mesovortex by this time, while the vortex to the south continues to tighten and strengthen. And again, at this point, to the north, we're looking at about 4,000 feet above ground level, and to the south, we're looking at about 4,500 feet above ground level. A couple more minutes pass, and there's actually now a tornado in progress with the southern vortex. It's not yet reached that 25 knot VR threshold, but it does continue to strengthen. Farther north, that vortex also continues to tighten and strengthen, and the surge in reflectivity becomes a little bit more apparent at that time. By now, I've realized that both of these vortices are probably going to require tornado warnings. You can see they're already covered by severe thunderstorm warnings. But now I'm being more reactive rather than proactive. So I'm playing catch up, so to speak. And I'm hoping that with this in mind, I can do a little bit better in the future if we have a similar such event. Now the next scan arrives, and both vortices have now reached the VR threshold of 25 knots. The southern tornado continues, and tornado genesis appears to be either ongoing or imminent farther north. Between this scan and the last one, I had made the decision to warn each couplet separately. And in hindsight, I think this was a mistake, or at least wasn't ideal, because first, I think it cost me potentially a little bit of lead time, at least on the northern vortex. And then secondly, having researched these QLCS tornado events somewhat in the past, albeit primarily in cool season events in the southeast, I know that when mesovortices begin to spin up roughly simultaneously like this, similar vortices could also develop along the line. So that's something I should have kept in mind going through this warning process. And I'll show an example of that from a southeast case here near the end of the talk. A minute later, we get our next sails cut. And by this time, the southern tornado had been in progress for a few minutes. And the northern tornado had actually just begun at that time based on storm damage surveys. But the first warning was on the southern tornado. Immediately thereafter, or at least as quickly as I could, the tornado warning for the northern vortex was issued at that time. And based on the damage survey of the southern tornado, that had actually ended by this time. As you can see, I mean, based on reflectivity and velocity, those two fields are pretty consistent with that assessment, as it does look like the vortex had weakened quite a bit by that time. Now on this scan, we see that another bowing segment has begun to develop, entering the party there between the two current vortices. And again, based on what has occurred with the other two vortices, we know that all three ingredients are met for this feature. Another vortex does try to develop north of the original southern vortex in the next couple of minutes as we go forward another scan. And the developing mesovortex southwest of Rochford, so south of that initial northern vortex, is also now tightening and strengthening. You can make a case for a little bit of a reflectivity nub there as well. And the northern tornado, based on storm survey, has now ended at this time. And I just wanted to point out, each of these tornadoes that have already occurred, they had durations of about 5 minutes or less, although we did not know that in real time. Going forward another couple of minutes, the two developing vortices continued to strengthen at this time. And both of these do have reflectivity nubs at this time, as I have marked there. The new southern feature is actually within my original tornado warning, but that middle feature is not. And by this time, I would say a tornado warning is probably warranted with that new tightening and strengthening vortex south of Rochford. A couple minutes later, the middle vortex has now, let's see here. Yeah, actually, fast forward another minute, and the new vortex is, that southern vortex actually weakened a bit at this time. So that was one of the exceptions on this particular night. Although it had the reflectivity nub, had all three ingredients met, this was the one that did not continue to strengthen. So I wanted to point that out. Not necessarily all of them are going to come to fruition and become tornadoes, but that one south of Rochford there continues to tighten and strengthen at this time. And a couple minutes later, that vortex has actually started to produce a tornado. There now appears to be a rear inflow notch and associated reflectivity drop in the vicinity of this feature. And I'm currently working on another tornado warning for this particular feature. Again, kind of playing catch up rather than being proactive. And around this time, we also have gotten a report of trees being broken and uprooted with that northern vortex a little bit farther west of where it is now. So we had a delayed report about 10 minutes after the damage actually occurred. And this is actually the only report we had of damage on that night of the event. Any other damage that we had was surveyed after the fact, as one of the meteorologists working that event actually drove through the hills just to get a sense of if there was any damage associated with these. And that's when we were able to identify the other two tornado tracks. Now the new tornado warning arrives as VR hits that 25 knot threshold again for that middle vortex. And again, unfortunately, this is a tornado warning with negative lead time. And I just wanted to point out here as well that there was a new product in the northern hills there, a flash flood warning that had been issued, that was issued by another Met on desk that night. And I just wanted to point this out because this, like most QLCS tornado events, was multifaceted. So it's important to ensure that you have adequate staffing before this type of event occurs, so you can handle all of the different hazards that these events pose. Now, a couple minutes later, the new tornado has now ended. So it's another tornado lasting under 5 minutes with this particular QLCS. And by now, the system scale outflow boundary is beginning to accelerate a bit. So on the west side of the hills, when it was moving uphill, the forward speed was about 30 knots. And now as it begins to reach the highest elevations and begins to descend down the eastern side, it actually begins to accelerate to approximately 40 knots. Now stepping forward another radar scan, the TORs are all still in effect here because I'm working on a new severe thunderstorm warning downstream. And we continue to get some interesting features along the line, even though we don't end up getting tornado genesis. And that's including potential nub and reflectivity west of Mount Rushmore and Crazy Horse along the southern edge of the line there. And you continue to get surging and bowing features elsewhere. A few minutes later, the outflow is really beginning to accelerate as it begins to descend down the eastern side of the hills, and also most likely just with the push of the rear inflow jet pushing that along there. Now, this was a tough decision with that northern vortex in particular, but I decided not to reissue the TOR up there, although the vortex was still fairly strong, and decided to just cover those as they moved eastward with a severe thunderstorm warning with the TOR possible tag. And there is that new severe thunderstorm warning. Generally speaking, the tornado threat this time appeared to be waning. a couple minutes later, we start to see those tornado warnings beginning to drop. And you do see that the vortex there in the northern end of the line near Rochford, that does attempt to re-strengthen at this time. And as the tornado warning drops for that particular vortex, it looks like it still tries to strengthen a little bit. But at this point, with the outflow surging so far ahead and that vortex being back in the cold pool a little bit, I'm not as concerned about imminent tornado genesis. And at this point, you start to see those vortices broadening a little bit as it goes 1 minute forward, a couple more minutes forward. Those vortices continue to broaden, and really it's becoming more of a straight line threat at this time. Now, going back to 219Z, this is the original southern tornado. And I wanted to point out that although no tornado warnings, or excuse me, no tornadoes here actually produced debris signatures, each of them was associated with a distinct circular maximum and spectrum width. And that was before, during, and after each tornado occurred. So this could be useful in the future because this type of feature is consistent with a coherent vortex. And it could be useful in at least identifying areas where you have a localized enhanced straight line wind threat, even if you don't end up getting a tornado. And there's that maximum there in spectrum width in the lower left. So here's the QLCS in all its glory. I'm going to let this loop through a few times. You see it really got going there in northeastern Wyoming near Newcastle. We had a report of a 69 mile per hour wind, an observed 69 mile per hour wind there in Newcastle. But overall, we didn't have a whole lot of reports with this particular event in real time. As I mentioned, we only had damage reports with that northern vortex in real time. And so that also led to some uncertainty when it came to issuing those tornado warnings. When you're not getting any reports in real time, it makes it tough to have confidence in what you're putting out. But overall, after the fact, we did have those 3 different tornado tracks, and actually the straight line wind damage continued east of Rapid City quite a ways throughout the remainder of the evening. We ended up with some actually measured wind gusts over 100 miles per hour as it started to move into Aberdeen's CWA. TJ Turnage, who provided a great talk last week, created some of those as shear, div shear, and velocity gradient animations for this case. I just have a couple of still examples here provided from 20 and 10 minutes at the top and bottom, respectively, prior to the initial tornado genesis. And I wanted to point out that the div shear here was really useful, showing increasing convergence in the vicinity of that northern vortex. And that was over 20 minutes prior to tornado genesis in this particular case. And the velocity gradient product, as expected, showed a similar maximum in that general area. So this indicates that these products could have been pretty useful in real time and providing even more lead time for the tornado warnings, at least along that northern part of the line, which happened to be a little bit closer to the radar there. And the as shear product, about 10 minutes prior to tornado genesis, also showed a really nice bullseye. So even if the radar operator happened to be waiting for an as shear bullseye in this particular case, that feature would have provided some more lead time than just waiting for certain thresholds of VR to be met, for example, although it is more complex, obviously, than just looking at one threshold. Just some quick reminders, mainly for the folks who don't experience many of these events. QLCS mesovortices do tend to be shallow, so they're typically 3 kilometers deep or less, and they're even best resolved in lower layers than that, so about 3,000 to 5,000 feet above ground. And they don't have accompanying mid-level rotation, so sometimes it's tough. You know, if you're waiting for rotation to show up at 4,000 to 5,000 feet above ground, like in this particular case, you may be missing out on what's actually happening near the surface there. And in some situations, farther from radar, rotation may not be detected at all. especially in shallower convection. Additionally, tornadoes, if any, as this event certainly showed, will typically be short-lived, though not always. And with that in mind, I kept the tornado warnings to 15 to 25 minutes in this particular event. But I would recommend, I think, at least 30 minutes in case any mesovortices do re-strengthen, as that northern one tried to do in this particular case. Because if there had been another tornado, I likely would have missed it based on having a shorter duration warning. And even if they don't produce tornadoes, mesovortices could be a focus for enhanced straight line winds. So when you start to get these three ingredients being met, and potentially some of those confidence builders or nudgers are met as well, then it's a good time to at least include a TOR possible tag in a severe thunderstorm warning. I mentioned this briefly earlier, but I've also seen some scenarios where these QLCSs can produce roughly evenly spaced spin-ups along their leading edges almost spontaneously. And this could be related to shearing instabilities, but I have a great example here of this occurring in Middle Tennessee during the cool season overnight QLCS in 2013. This is a radar image from that particular case. And if you look at the leading edge of this this QLCS, look at all the mesovortices there. Many of these produced tornadoes as well, and this all occurred roughly simultaneously. A very interesting case. This actually ended up being the second largest tornado outbreak in Middle Tennessee history. It was the middle of the night in January along the QLCS, but just because of how prolific this particular QLCS was in producing these mesovortices, that most of which strengthened to tornado strength, it became the second largest tornado outbreak in that particular area. So very interesting case, and that's the kind of thing I like to keep more in mind as we deal with some of these events in real time. Obviously, our QLCS didn't become this prolific, but it's a good reason to potentially not try to sharpshoot each vortex. And also some things that we've been talking about here locally, and I know it's been a subject of broader research as well. We think that the tornado threat could increase as QLCSs or even individual storms begin to move up terrain. This has been observed in other parts of the country. In northern Alabama, this is a big research topic as well. And it could be associated with numerous different factors. It could be associated with the impact that terrain has on the cool pool shear balance, the development of vorticity, or even the near storm environment. And along with all of the other research that's ongoing, we hope to do some more research to that end in the future here locally in the Black Hills. Now it's 2020, so it's a good year for reflection. And in hindsight, I may have just issued that one tornado warning from the initial southern vortex to the initial northern vortex. This would help with lead time on the second and third tornadoes that we had, and it would have accounted for any other mesovortices that developed along that line. And I think in this particular case, the squall line with embedded tornadoes basis for the warning would have been appropriate, because this specifically mentions a line of severe thunderstorms that are capable of producing both tornadoes and extensive straight line wind damage. And I think that would have been appropriate in this case. Now, more than anything, what I should have done differently is just trusted the environment, the radar, and also the three ingredients method. Because sure, tornadoes, QLCS tornadoes are rare here in the Black Hills, but the same meteorological principles hold whether an event is rare or not in a particular location. And using these methods could have at least helped provide a little bit of lead time. And fortunately, these tornadoes occurred mostly in forested areas, like I mentioned early on. They didn't produce impacts to life and property, but we can't always count on that being the case. So I'm hopeful that looking back at this event will help us do a little better, me do better personally as well when I'm on the warning desk, and just give some some more tools in the toolbox for folks who are looking for example events like this. So just to summarize real quick, I talked today about that rare tornadic QLCS over the Black Hills that produced 3 different EF1 tornadoes last July 4th. It was mainly in forested areas, kind of dodged a bullet in that particular case. These were all warned, but they were all warned with negative lead time. The environment and the radar features that are highlighted in the 3 ingredients method, along with the TWIP, nudgers, and confidence builders, plus the new div shear and velocity gradient products being created by TJ Turnage, all suggested that modest lead time was possible, despite the range from radar that had us looking at 4 to 4.5 thousand feet above ground level out there. And I do think that confidence in the environment and the use of this 3 ingredients method and the TWIP nudgers and confidence builders can allow us to be a little bit more proactive in future events rather than being reactive. So I'll leave my email here if you have any further questions after today, but I'm happy to take some questions right now as well if we have time. Thanks.